Welcome back as we continue our wonderful journey in additional mathematics. My name is Nanaya Wedu and you can call me Say Nana. Remember to share this video, like this video, comment on this video if you find anything interesting or you want to ask a question. And remember to click on the notification bell and subscribe to my YouTube channel. In our previous lesson, we've considered the inverse element of a binary operation and we've used an example to be able to solve for the inverse element. For us to be able to practice more in this lesson, we are going to consider another example on the inverse element. Now let's move in and look at the example. So the example says that a binary operation, and the operation symbol is here, is defined on a set of real numbers r by x operation y to be equal to x plus y over xy. And first, you have to find the inverse of the element s under the operation. And we have to find the inverse of 4 under the operation. So now let's consider a solution for this question. So basically, the operation given is x, and that's the operation symbol y to be equal to x plus y all over xy. We can say that let x inverse be the inverse of x, right? Such that x operation, x inverse is equal to identity element. So by now we know how to find the identity element. We know that x operation, the identity element is equal to x. So we can say that x operation, the identity element should be equal to x plus e all over xe, right? And we can equate x plus e all over the xe to be equal to x. Then we can actually go through the algebra of simplifying this. We divide this by 1 and we have x plus e to be equal to x squared e. Then we group like terms with the e, so we have e minus x squared e to be equal to x. Then we can factorize e out here because we have e here, we have e here. So we are going to have e 1 minus x squared to be equal to x, right? So it means that we will have this to be all over 1 minus x squared, and then this side will be equal to 1 minus x squared, right? Remember that this x is moving across the equal to sign, so it's negative, so minus x. So we can divide both sides, and then we will have our e, right, which is our identity element, to be equal to negative x all over 1 minus x squared. So now we can find our x operation, x inverse, right? And we know that that will be equal to s plus s inverse all over x inverse. So we can equate x plus s inverse all over x inverse, which is x operation, x inverse, which we find here, to the identity element. And we know the identity element is what we found here. So it's equal to minus x all over 1 minus x squared. So we can cross multiply. We have 1 minus x squared bracket. So we have x plus s inverse is equal to minus x brackets x inverse. So it means that in expanding, what this implies is that we are going to expand the 1 over this, and then we'll expand the minus x squared over the second expansion here. So let's do that expansion and see. So we have 1 multiplied by x plus 1 multiplied by x inverse minus s squared multiplied by x minus s squared multiplied by x inverse, right? And that will be equal to this side, then x and then the x will multiply to give us negative x squared x inverse. Right, so let's expand this. So expanding this, we get x plus s inverse minus x squared x, right? And then minus s squared s inverse to be equal to negative x squared s inverse. So once we have this, the next thing we must do is to group all the like terms. So we'll put all the inverses at one side and put all the other variables at the other side. So let's look at the distinguishable here. So we have s inverse minus s squared s inverse plus s squared s inverse to be equal to, so we'll move all the other ones here. So we have x squared x minus x, right? So we are going to have s inverse, which will factorize out, will give us 1 minus s squared plus s squared, right, is equal to x squared x minus x. So in this case, we can divide both sides by the coefficient of the x inverse. So we are going to have s inverse s, right, 1 rather. So let me clean this. So 1 minus x squared plus s squared, right, all over 1 minus s squared plus s squared to be equal to x squared x minus x all over 1 minus x squared plus s squared, right? So this will cancel this. Remember that x inverse will be here. So you have x squared x minus x, because this would also cancel this. Minus x plus x will be left with 1. So it's like over 1. So it means that x inverse becomes equal to x squared x minus x. So it means that if you want to find the inverse of 4, that will imply that we have 4 squared multiplied by 4 minus 4. So you are going to have s inverse of 4 to be equal to 16 multiplied by 4 minus 4. So our 16 multiplied by 4, 4 will give us 24. So 4 times 1 will give us 4 times 2, which will give us 64 minus 4. So it means our inverse of 4 should give us 60. So this is our II part where we found the inverse of 4. And we've been able to find our inverse of the matrix to be equal to x squared x minus x. So in this lesson, we've gone through the process of finding the inverse of a binary operation, and especially finding the inverse when a particular number is given, where we just substitute the number in place of the variable to be able to get a whole number or probably a fraction. In our next lesson, we'll be considering another way of finding an inverse, especially when you are given a table. See you in the next lesson.